Hi everyone. Today we're going to evaluate definite integrals. In evaluating definite integrals, say the integral from a to b of f of x dx, step 1 is evaluate this as indefinite integral. That is the integral of f of x dx. And then the resulting is a capital F of x. This time, we will not add the c. Step 2 is, by fundamental theorem of calculus part 2, we're going to evaluate this function capital F of x with respect to the limits of integration. So we have f of b minus f of a. Let's see this example 1. Evaluate the integral from negative 2 to positive 2 of the function t squared minus 4 dt. For our solution, let us evaluate as indefinite integral. So we have now the integral of t squared minus 4 dt, and we have the integral of t squared to be t cubed over 3 minus the integral of 4 is 4t. Now the step 2, we will evaluate the resulting function using the limits of integration. So we use the negative 2 and 2. Most of the books of calculus, you will see this notation. And this is the same with f of 2 minus f of negative 2. So the f of 2 is now 2 cubed over 3 minus 4 times 2. Then minus this f of negative 2 is the cube of negative 2 over 3 minus 4 times negative 2. We simplify the 2 cubed to be 8, then over 3 minus 4 times 2 is 8 minus, now the cube of negative 2 is negative 8 over 3. Then negative 4 times negative 2 is positive 8. Let us now remove the grouping symbol, and considering the second group is preceded by a negative sign, we're going to change the sign of the terms of the second group. So we have now this 8 over 3 minus 8 plus 8 over 3 minus 8. We will now simplify these numbers into negative 32 over 3. This is our final answer. Example 2. Let us evaluate the integral from 1 to 9 of the function x minus 1 all over the square root of x dx. For our solution, let us rewrite the integral and show that this radical sign here is a fractional exponent. So we have now the integral from 1 to 9 of the function x minus 1 all over x raised to the fraction 1/2 dx. And from here, let us distribute the denominator to each of the term of numerator. So we have this x over x raised to 1/2 minus 1 over x raised to 1/2. And let us simplify each of the fractions. So we have this x raised to 1/2 minus x raised to negative 1/2. And from here, let us do step 1, and that is to evaluate as indefinite integral. Using the power rule, this x raised to 1/2 is now equal to x raised to 1/2 plus 1 all over the denominator 1/2 plus 1 minus this x raised to negative 1/2 has the integral x raised to negative 1/2 plus 1 all over the denominator negative 1/2 plus 1. Simplifying further, this 1/2 plus 1 is 3/2. So we write here x raised to 3 over 2 all over 3 over 2 minus the x raised to this negative 1/2 plus 1 is positive 1/2. So we have here 1/2 as the exponent all over the same 1/2 as denominator. Let us simplify this further by flipping the denominator and making this denominator 2 to be coefficient of x in the numerator. So we have 2x raised to 3 over 2 all over 3. Then for this, minus 2x raised to 1/2. And from here, we will go to step 2. That is the f of b minus the f of a. And we say that in some books, you will see this notation, a vertical line, and we put the limits of integration, the 1 and the 9. So we have now 2 times 9 raised to 3 over 2 all over 3 minus 2 times 9 raised to 1/2. Then minus the f of a. We have 2 times 1 raised to 3 over 2 all over 3 minus 2 times 1 raised to 1/2. Simplifying further, this 9 raised to 3 over 2 can be simplified into 27. This 9 raised to 1/2 is 3. This 1 here raised to 3 over 2 is simply 1, and 1 raised to 1 over 2 is 1. You see here the 27 and 3 can be simplified into 9, and 9 times 2 is now 18. Then minus 2 times 3 is 6. Then minus the second group now is 2 times 1 is 2 over 3 minus 2 times 1 is 2. From here, let us remove the grouping symbol. So we have now 18 minus 6 minus 2 over 3 plus 2. So the final answer here is 40 over 3. Example 3. Evaluate the integral from 0 to pi over 2 cosine theta d theta. For our solution, let us evaluate as indefinite integral. So the integral from 0 to pi over 2 of cosine theta d theta is equal to sine theta. Then the step 2, capital F of b minus capital F of a. So the notation is here from 0 to pi over 2. So the f of b is now sine of pi over 2, then minus the f of a, that is sine 0. Let us evaluate the values of the corresponding signs here. But take note, in our calculator, it must be in radian mode. So the sine of pi over 2 is 1, then minus the sine of 0 is 0. 1 minus 0 is simply 1. This is the final answer. I hope you learned something from this video. See you again next time.